Yes, good morning students, dear students. Hello, how are you? And now we are going to discuss in continuation with the chapter Work, Energy, Power, that is chapter number 6, part 5. In part 4 of the video lecture, we had discussed about the work done, and the work done we had discussed about the conservative forces, examples of conservative forces, that is the gravitational force and electrostatic force, then non-conservative forces, and in that we had discussed about the tension, spring force, frictional force, work done by these forces we had discussed. Now today we are interested to discuss certain numericals based on this. So one numerical is in front of you. Look at the numerical. What the numerical is saying? The numerical says that a wooden block of mass 1 kg, this wooden block is of mass 1 kg, is pushed up a surface inclined to the horizontal. This is the horizontal surface, and this surface is inclined to the horizontal surface at an angle of 30 degree. The inclination is of angle 30 degree by a force of 10 Newton. This force is of 10 Newton to the inclined surface. So let us see, start writing what is given. Given here, m is equal to mass of the block is equal to 1 kg, is pushed up the surface horizontal, angle theta, inclination is equal to 30 degree by the force of applied force F is equal to 10 Newton. Parallel to the inclined surface, the coefficient of friction of the block and the inclined plane, that is mu is equal to 0.1, it is given. If the block is pushed up 10 meter along the incline, now it is pushed up 10 meter along the incline, so distance is equal to 10 meter, s is equal to 10 meter. It is given s is equal to 10 meter. Then we have to calculate work done against gravity is equal to what, work done against force of friction is equal to what, and you have to calculate also the acceleration of the block. These three things we have to calculate in this. These three things we have to calculate in this. So first of all, so dear students, first of all we will resolve and draw the free body diagram. So this angle is theta, so this angle is also equal to, this angle is equal to 30 degree. This angle is also equal to 30 degree, and the component of mg is mg cos 30 degree in the vertical direction and vertical to the incline, in the vertical direction downward to the incline, and the component of force mg along is in this direction is mg sine 30 degree. Now we have to calculate the work done against gravity. The first we have to calculate work done against gravity. We have to find work done against gravity, and work done against gravity, that is Wg, it is equal to what, Wg against gravity. So against gravity the force is acting, that is equal to mg sine theta. mg sine 30 degree, this component of the force, and mg sine 30 degree, and it displaces to a distance s into s. Mg sine 30 degree, the work done against gravity is mg sine 30 degree into s, and it is equal to 1 into 10 into 1 by 2 into 10, and it is equal to 100 divided by 2, that is equal to 50 Newton. That is equal to, since we had already written against gravity, so we had not put negative sign here. Against gravity it is written. If we used to write here work done by gravity, then we have to put a negative sign. So since it is already written against gravity, so we had not put negative sign over here. So that is equal to 50 joule. This work done is equal to 50 joule. Now second one is work done against force of friction, work done against friction, work done against friction. So work done against friction, Wf is equal to F into S, and F into S can be written as mu R into S, and mu R is equal to mg cos theta. So we can write that here, from here we can write it as R is equal to mg cos 30 degree. R is equal to mg cos 30 degree. So we can write it mu mg cos 30 degree into S. Now putting the values, mu it is given 0.1. Mu is equal to 0.1 into m 1 kg, g 10, and cos 30 root 3 by 2 into 10, root 3 by 2 into 10, and it is equal to 5. So and 10 into 0.1, 10 into 0.1 is equal to 1. So this is equal to 5 root 3 Newton, 5 root 3 joule. Here also we had written against friction, so no negative sign we had placed here, and it is equal to 8.66 joule. Now we have to calculate the acceleration. The next thing we have to calculate acceleration. We have to calculate acceleration in the block. Third one is acceleration in the block. So acceleration in the block is equal to F minus mg sine 30 degree minus mu mg cos 30 degree, mg sine 30 degree mu mg cos 30 degree is equal to ma. Am I right? F minus mg cos 30 degree mu mg cos 30 degree. Now taking the shifting to that side, that is F is equal to F minus mg cos theta. So F is equal to ma plus mg sin 30 degree plus mu mg cos 30 degree. Now taking m common, mu mg, or you can write here like this. You have to calculate the acceleration, so it will equal to F minus mg sin 30 degree minus mu mg cos 30 degree divided by m, that is equal to a. Now putting the values, F is given in the question. F is given in the question by the force of F 10 Newton, by the force of 10 Newton. So this is equal to 10 minus 1 into 10 into 1 by 2 minus 0.1 into 1 into 10 into root 3 by 2 the whole divided by 1, that is equal to A, and it is equal to 10 minus 5 minus this is equal to 1 into 1, that is equal to root 3 by 2, that is equal to A, and it is equal to 10 minus 5 minus root 3 by 2 is equal to A, or A is equal to 10 minus root 3 divided by 2, or A is equal to 10 minus 1.732 divided by 2, and I think it will be equal to 4.13 meter per second square. 4.13 meter per second square. So acceleration of the block equal to 4.13 meter per second square. This is the acceleration of the block. I hope it is clear to you. Very simple question. You have to solve. Okay, clear students? So these things we have to calculate, and we have to calculate all these things. Now move to the next numerical. Now dear students, look at this numerical. This numerical is from IIT Mains. And in this numerical, it is asked that a block of mass m moves gradually on the rough inclined surface such that force F acts always tangential to the surface of the hill, which is rough. This is the surface of the hill, and this is the rough incline, and here the block is moving. So you have to calculate the work done by the applied force F. Work done by the applied force F. We have to find the work done by the force, work done by the applied force F, we have to calculate. So for this, look at here, we had drawn a diagram, and what we had considered, suppose this is the block, and it moves a small distance ds. We had considered a short distance ds which is moved by the block, and it is supposed as ds. Now suppose this is the horizontal and this is the vertical. This is the horizontal and this is the vertical. So in horizontal direction it had moved dx, and in the vertical direction it had moved dl. Suppose it had traveled ds distance, so I had supposed this dl distance and this distance is dx, and suppose this angle is theta, so this angle is also equal to theta. This angle is also equal to theta, or you can, it is better that you can suppose it as dy. Suppose it as dy. So taking this triangle, this small triangle, suppose this theta, this angle is theta, this distance is ds, the small distance moved by the block of mass m, this distance is dx, and this distance is dy. Now dear students, now we are capable of calculating the value of cos theta, here. So from here, from this diagram we can calculate the value of cos theta, and the value of cos theta is equal to base upon hypotenuse, that is dx upon ds. Leave it here, dx upon ds. Now look at here. Now we are going to our another part. This is the value of cos theta because it is used in the later calculation. So we had explained it here. We had taken a small part of the movement of mass m on this rough inclined plane, and that small part is ds. For this small part, this distance is dy and this distance is dx. From this we had considered the triangle, and from this triangle we had calculated the value of cos theta, that is dx upon ds. I hope it is clear to you. Now here it is written in the question, the block of mass m moves gradually means very slowly. So very slowly we can suppose for gradual movement of block, we suppose V is approximately equal to 0. V is approximately equal to 0. Now dear students, from the theorem, work energy theorem, which we will discuss later. So from that theorem, that is from work energy theorem, we can write that net work done by the force F, is equal to change in kinetic energy, and that is K final minus K initial. And here it is written that the V is equal to 0, change in velocity is 0 for gradual movement. For a small movement we had supposed, for a small distance we had supposed the velocity is equal to 0. So for that small interval the net work done is 0. For that small displacement, net work done 0, because final kinetic energy is same as initial kinetic energy, that is delta K is equal to 0, because V is 0. So delta K is 0, so net work done is equal to 0. Now we are going to draw the free body diagram. Let us draw the free body diagram of the block. Suppose this is the block of mass m. So weight mg is acting in this direction. and this angle is theta. So, and this is the normal reaction N. So, this is considered as mg, this angle is also equal to theta, and this is considered as mg cos theta. This is the frictional force and this is the applied force. This is the frictional force and this is the applied force. Now, we can find out the work done. First of all, calculate the normal reaction. Normal reaction is equal to mg cos theta. So, calculate here. Normal reaction here, normal reaction is equal to mg cos theta. So, cos theta we had calculated ds, so we can write it mg into dx upon ds. This thing we can write dx upon ds. Now, for different forces, we will try to find out the small work done. So, since dw by applied force is equal to 0 from here, net work done dwf we had calculated, and we can write that dwf is equal to mg into dy plus f into ds. Look at here, students, why you had written here? Because this weight is responsible for upward motion, and in this direction motion, it is, if the weight is lifting, then it is due to the component of the weight mg. Due to the component of the mg, the vertical motion is going on, and due to the frictional force, the horizontal to the inclined plane, this motion is going on. So, we can write it as dwf mg into dy plus f. F can be written as mu into n into ds. Mu into n into ds. Clear, student? Now, look at here, mg into dy plus mu n into ds. Now, it is clear. We can write here dwf is equal to mg into dy plus mu n is equal to mg dx upon ds into ds. Clear? Now, it will be cancel out. So, we can write it as dwf is equal to mg into dy plus mu mg into dx. Mu mg into dx. So, students, now we have to calculate the net work done. We had not mentioned here the work done by normal reaction. This work done by normal reaction is equal to 0. So, let us calculate. Now, integrating both sides. Integrating both sides. On integrating dwf, that is equal to mg dy, and suppose this length is L and this is x. This is x and this is L. So dy 0 to L, 0 to L plus mu mg integrating 0 to x dx and dwf is equal to m into g is taken out and it is equal to y 0 to L plus mu mg is taken out and it is equal to x 0 to x. And it is equal to Wf is equal to mg L plus mu mg x, mu mg x. Yeah, if h, it has supposed height h, and this distance is 0 to L, 0 to L, x 0 to L, so it is equal to L. So net work done is equal to mgh plus mu mg L. Now there is a question in your mind, students, why we had not considered the work done by this normal reaction, because there is no movement in this direction. Work done by normal reaction is equal to 0 because there is no any movement along direction of n. There is no any movement along the direction of n, and since there is no any movement along direction of n, so work done by n is equal to 0, and we had not included the work done by normal reaction. We had included the work done by friction and the work done by mg, because due to the component of mg it is moving in this direction. So that's all, students. This is all about this question. So these are the two good questions we had discussed. Now in the next discussion we are going to discuss about the kinetic energy.